For your next project, you're going to work on a game called Endodoi, which is a variant of the game Mancala. This is a game in which there's a board with multiple seeds, they're called, or in this case stones, and the player will make choices of where to select stones and then carry them forward from spot to spot, pit to pit, as they're called in the game. So your task for the first part of the project will be to create a board representation that we can use in a text-based version of this game. And down below, I've used the R code to recreate this board that you see up above. It's got all of the same features and a few more that we need to be able to use as a text-based interface. You can see the pits with the various seeds or stones in them. Each pit has 4 stones in this example image, and each pit has 4 stones in the display of the text-based version down below. One thing you can see we've added is labels so that the player can select which pit they'd like to take stones from and move to other pits. There are also spaces for players to store stones which they've captured, and ours has that as well. On the picture, they're on opposite sides of the board. On ours, a player's items are all in a single row. So this row belongs to player 1, and this row belongs to player 2. Whatever they've captured will end up showing up in their store here. One more thing that we've done is we've added a space to indicate which player's turn it's going to be, because we don't have a mechanism for indicating that like people would do verbally. Let's take a look at the code to see how we actually put together the pieces for this. For this part of the project, you're going to need to work on 3 different methods. 2 of them will be necessary to then be able to use for the third. You will need to be able to create a new set of pits. That will give us the values, a 2D integer array, of how many stones are in each pit. And to start out with, each stone will have the same number of each pit will have the same number of seeds or stones in it. We also need those labels so that the player can select which pit they're taking from and know which pits are being put into as well. So we'll have a method for creating the characters that represent those different labels. A 2D array of characters will come out if we give it an array of pits that it can design some labels for. And then we have the draw board method that actually does the work of putting it all together into a single board, and we'll dig into some of the details of how that works as we move forward. First, I want to show you how I would test my create new pits method. You can see here that I've set up a variable called player pits, and I've called to create new pits, telling it I would like 6 pits per row. We know there will only be 2 rows, so we don't need to indicate the number of rows. All we're really indicating is the number of columns, the number of pits in a row. And then how many seeds should be in each row to start with. So this is used at the start of the game to design the 2D array that represents sort of the state of what seeds are available and what can be done. So I'm going to uncomment this line, which will show me the output from create new pits. You'll notice I'm using this utility function, arrays.deep2string, that allows me to print out a 2D array. It can be very useful. You might try to use it in your code. When we run this code, we'll now be able to see the result for create new pits. I tell it there should be 4 pits per row. I'm sorry, this is incorrect on here. It changed it to 6 and 4. And so now there should be 6 pits per row, and there should be 4 items in each pit. 6 pits per row, 1, 2, 3, 4, 5, 6, and there are 4 in every single spot. So that's all that method needs to do. And I can test it out for another value as well. For example, if I want to do it with 4 pits per row and 1 item, 1 seed in each pit. And we'll see that down below our board that printed. Create new pits with 4 and 1. 1, 2, 3, 4 of them, and 1 in every single location. So that allows us to have a start of a game, and we'll see that that is being fed to the drawBoard method as the pits that give it the values to print out inside of the board. The other thing our program needs to be able to do is to create those labels so that the player can choose which pit they're going to take from as they play the game. We have the method player pit labels for that, and all it takes is the 2D array of pits. That tells it how many rows and how many columns, and that's pretty much all it's going to use from it. It does not care whether those pits are empty or full or anything else. It's just going to use it to tell the size of how big the 2D array of labels should be. So it will return another 2D array, this time of characters, and we've saved that here in this variable player pit labels. So when I run that, we can see the result right under create new pits. So we create the new set of pits, six pits in each row with 4 items in each one. The labels don't care how many are in it. You can see that there are 6 characters here in the first row and 6 characters here in the second row. That's really all it's doing, is splitting up these alphabetical characters into the 2 rows and giving them the right number in each row. And then finally, that's what's used to print out in our board here. So again, I can test this for the other value here to print out the labels when it was 4 pits per row, and we should see that it has a different size to it, but is still using A, B, C, D, E for those labels. A, B, C, D for the first row, and then E, F, G, H for the second row because it was 4 pits per row. So now is the more complicated one, which is draw board. It takes that set of pits, which gives it the values and tells it how big each row should be, how long each row should be. It also takes the number for the stores here so that we can see if the player has already captured some things. For example, if I change these stores, we'll start to see those values displayed in the store spaces for each player. When the player has nothing, it's just left empty. We don't put a 0 there. That draws your attention to which things are empty. So the store values are what shows up here to show sort of the score for each player, how many things they've captured. There's also an indicator for which pit has been selected so that the player, when they choose which pit they're going to play from, we can show updates where it shows that pit. So here, for example, in the one with 4 pits per row, we've used the character G to say the player indicated that they'd like to play from G. So now when I run, I'll see a new board down here for the one with 4 pits per row. So you can see the player pits has a strong impact on how the board prints out. It gives us all of those values. And we can see that E, F, and G is indicated now with a star to show it's the one that's been selected. If nothing was selected, we show all the labels for that row. Another thing to notice is we can indicate which player's turn it is. Up here I used -1 to say it's no one's turn right now, and there are points in the game where that will be useful. But then down below I changed it to say player 2's turn will be happening right now. And the item that was selected is one of the items in player 2's row. We can see the X here indicates that it is player 2's turn, and then the star indicates which one has been selected. Whereas, for instance, here, we've got basically the same arrangement, except I've said no pit is selected yet, and the player's turn is too. So when I run that one, we'll see the only difference is that G is not indicated with a star. It's just left as the letter G because no pit has been selected right then. That's what using something other than a character value here indicates. And finally, we have the case where we give all the same things as above and we indicate that it is no one's turn. So when we run with that, the thing that should change is the X will disappear and all of the labels will be shown. So X up here because it was someone's turn, but there was no selected pit. And only that bottom row, the one whose turn it was, is shown. Here, no player turn in, no selected pit means that all the labels show up and there's no X for anyone, much like the very first one that we showed in the video. So the important things to take away are that there are these 3 methods. We will need to create the pits and the labels We'll need to be able to create the pits and the labels first before we're able to draw the board. Create new pits gives us the array of player pits that will be passed into draw board as a parameter, and player pit labels will give us the array of labels which we're going to use inside of draw board. It does not get passed as a parameter. And then finally, draw board will allow us to draw various configurations of the board, sometimes where players have a score, sometimes not, sometimes where a pit has already been selected or not, and then sometimes indicating which player's turn it is.